Hello teachers, my name is Ngọc Linh and today I'm represent for our team to present to you our midterm project about the flyweight pattern and facade pattern. The first is the flyweight pattern. I will go through three main parts. The first one is a real life example, and the second is the flyweight pattern definition, and finally is the software flyweight example with the demo code. Um, we go to the real example of the flyweight pattern. It could be found in the computer graphic application, where we need to display a large number of graphic objects such as circles, squares, triangles, except has attributes like color, size, and position. So if we create a new object for each step, whenever it needs to be displayed, it would be consume a lot of memory, especially when dealing with a large number of steps. They can be lead to the resource wasted and reduced performance. Applying the flyweight pattern in this case helps solve this problem by dividing the unchanging attribute for the graphic object into the separate object called a flyweight. These attributes are shared by all graphic objects, reducing the amount of memory required. With the based on this example, the above example, we will go to the flyweight pattern definition. The definition of the flyweight pattern is either structural design pattern used to reduce memory uses or the number of objects in application by sharing data between objects when it possible. And the two is the problem of this uh, in the application with the large number of similar objects, creating a new object for each instance can lead to the resource wasted, especially in memory context. And with the problem, we have a solution. Instead of creating a new object for each instance, we separate the unchanging attribute into the separate object called a flyweight and share this flyweight among objects. And here is the flyweight pattern structure. With the flyweight class, it is an interface or an abstract class defining common method for an unshareable object, and the concrete flyweight it implement the flyweight interface and provides specific method for intrinsic state. And the flyweight factory class it create and manage the flyweight object. With the unshaped flyweight, although the flyweight design pattern allows for information sharing, it's impossible to create instances that are not shared. In such cases, the information of this object may be stable. And we have another client class. It utilize flyweight object to perform its task. Uh, and we have the flyweight pattern demo here with the problem that developing a beverage shop management application. This application needs to store information about the various type of beverage. Each type of beverage may have common attributes such as name, price, ingredient, and size. And the coffee shop offer dozens of type of beverage with many different size. Storing in this information in memory can be costly and affect the performance of application. And in the flyweight class, it design a flyweight interface define the common method. It get the design name and design value that on-site object flyweight share, and the concrete flyweight class. This is the side flyweight implement. This class implement the side flyweight interface and represent the concrete flyweight object. And the flyweight factory class, the Zybun class, is this lab apply the flyweight factory to some extent, and the client's class is the other client class. In this example, the class actually the client class, and it will be called for the uh, beverage factory like something like it order beverage, and they will order through this. We have some code here. in here we add a total eight beverage, but we just with the four size of beverage like small, medium, large, and super large. So it just take total time work in 12 seconds instead of if we create each beverage separately, it will take 24 seconds. Now we go into the last of the flyweight pattern part. Uh, is where the benefits of flyweight pattern reduce the memory uses in the application, improve performance by reducing the number of objects created and managed, and the last is optimize resource uses and enhance the application's capability. And the Facade pattern is a useful tool for simplifying complex systems, but careful consideration is needed before applying it to simple systems. And now we go into the second pattern today, is the facade pattern. We also go through three main parts, and the first part is a real world example. Here we have the example in this dishwasher. Uh, this process involves steps such as washing, rinsing, and drying. Each of these steps may involve multiple actions and different processes, and managing them can become complex. And applying the Facade pattern, we will have addressed this issue by providing a simplified interface for interacting with the dishwasher, hiding the complexity of the internal function, and provide a single entry point of invoke the dishwashing processes. And based on this example of design pattern, we go to the Facade pattern definition. Facade pattern definition. Uh, the facade pattern is a structural design pattern that provides a simple interface for the set of more complex interface within a system, helping them to reduce complexity and provide a single entry point for the interaction. And the problem here is in the large system, there may be many complex layers and components that client needs to interact with, making them usage um, difficult, difficult and complex. And we have the solution here is apply the facade pattern. It provides a simplified intermediate layer like a facade class to interact with the complex component within the system, provide a simple and unified interface for the client. There is the Facade pattern structure. When we use the Facade on the subsystem, class is with the Facade. In here, we go to the main component. The Facade is intermediary class providing a simple interface for user. It's responsible for receiving requests from user, and it is communicating to the subsystem to fulfill the request and return the result to the user. Uh, and the additional facade, it can be created to avoid complexity in a single facade. And the subsystem, they are the classes providing specific functionality of the system. And the last is the client class. There is the classes using the facade to interact with the system. Here I have the facade pattern demo. I want to build a simple system to manage gym membership registration. The system needs to meet the following requirement. Allow user to register for different type of membership, calculate membership fees based on the selected membership type, support payment via credit card or cash, and send a welcome email after successful registration. And the model class here, you can see that the client need to interact with the gym facade to register the type of membership if what they want. And here is the code. They have like a subsystem like payment service or welcome email service. Uh, and the client, it just needs to interact with the gym facade and to register the type of membership. And now we're going to the conclusion of facade pattern. The benefit of using this, uh, that's the first one, to increase the simplicity. The facade pattern provide a simple interface for user, making it easy for them to use the system without needing to understand the internal implementation details. And the second is improve the flexibility. The facade pattern facilitates easy changes or intention to the system without affecting how user interact with it. And the last is the enhance the security. The facade pattern can be utilized to hide uh, sensitive system detail from user, those improving security. And for the conclusion, the facade pattern have to reduce the complexity and increase flexibility in the developing and maintaining system by the providing a simple and unified interface for client to interact with the complex component within the system. And this is all about our present for you today about two pattern, that flyweight pattern and facade pattern. Thank you for your listening our team to present, and hope you have a good day. Thank you.